And welcome to this video on 3D shapes, volume and surface area. Okay, so what we're going to do first is just look at the various shapes dotted around this page, and we're going to put them into categories or groups. Now on the left we have prisms. Okay, now there's two already in there. There's a cuboid and a hexagonal prism. Okay, and another two which are here. Let's just find them and move them in place. This one here is a prism. The clue's in the name, a triangular prism. And we got another one here which is a kind of prism. Okay, some maths books don't like cylinders being called prisms, but in fact they are, in the sense that they have the same properties. Okay, and what are those properties? Well, if you slice it along its length, any of these shapes here in this group, you always get the same shape and the same size. Okay, so if you slice this along here horizontally, you're going to get equal triangles every time. Okay, so it has what we call the same cross-sectional area all the way through. Whereas a pyramid has a shape on the base, but all of the points from every vertex on the base converge to a single point above it somewhere. Okay, and they're called pyramids. And again, a cone is a kind of pyramid because it's all coming from a circle on the base to a single point. And finally, we have the odd one out, which is a shape that's neither a prism nor a pyramid, which is a sphere. And there are other 3D shapes that don't belong to any of the above categories, but the only one we're concerning ourselves with area and volume is a sphere. Okay, so they are the sort of three groups of shapes that we're dealing with. Now, before we move on to some examples, I want to explain to you one of the properties of a pyramid. It's really important that you understand this. So I've just done a little sketch down the bottom here. And if we just take 2 dimensions for a moment and consider a triangle, all 3 of these triangles here with the same base length of x have the same area. Okay, by tilting the point to one side, as long as it's the same height above the baseline, then it will be the same area. Okay, so even if it's skew like this one, leaning right across, all 3 of those have the same area. Now, in the same way, a cone or a pyramid has the same property. So, for example, if these were looking at, say, a cone sideways on, it wouldn't matter if the top of the cone was centrally above the base, like this one, or over to one side, or leaning right over. They would all have the same volume as each other, because they have the same height, and as long as they have the same base area, then they would have the same volume. Okay, and there's a very interesting connection between prisms and pyramids. And I simply summarize that by writing down one fraction. Okay, I'll just put it here. And that's the fraction 1/3. Okay, now I'll explain what I mean by that. If you took this cylinder here and it had a circle of a certain area and a certain height, and the same circular area was used to make the base of this cone, with the same height, then the volume of that cone would be exactly 1/3 of the volume of the cylinder that it was cut from. Okay, and that's true of any pyramid. So we get these general formulae here. So if you have a prism, if you know the area of the cross section, okay, and multiply it by the length of the prism, or the height if it's tipped up like this one, that will give you the volume. Okay, now with a pyramid, if you know the the base area, okay, the base area, you times that by the height, but you also times it by 1/3. which will give you the volume. Okay, and a cylinder is just an example of a prism in that the base area is the area of a circle, which is pi r squared, and you multiply that by the height of the prism or the length of the prism. A cone is just like a pyramid. Okay, the volume of a cone is a third of the base area pi r squared times the height. Okay, that's the volume of a cone. Okay, now I'll just mention a sphere. Okay, and there's a formula for the volume of a sphere, which is simply 4/3 of pi times the radius cubed. Okay, so if you know the radius of a sphere, you cube it and times it by 4/3 pi. You don't need to know how to prove it or anything at GCSE, but you just need to be able to use it. Okay, now finally there's mention of surface area. Okay, so the surface area of something is the total area of all of its surfaces added together. Okay, now in most shapes it's just a question of unpacking it and working it out. So for example, in a cuboid, you've got two ends the same, you've got a front and a back the same, and a top and a bottom the same, and you would just add those 6 areas together. In the case of this triangular prism, you'd need to know the area of the 3 sides around it plus the 2 ends. Okay, it's a bit like imagining a net of the shape opened out and flattened. What would the area of that be? Okay, now the special formulae concerning cones and spheres. So if we take the cone, okay, to find the curved surface area, that's not including the circular base, just the curved piece. Okay, you use this formula, pi r L, and L refers to what we call the slant height, not the vertical height, the sloping height, L, of the cone. Okay, so if you wanted the total area of a cone, you'd have to do pi r L plus pi r squared, which is the area of the circular base. The formula for the surface area of a sphere is 4 pi r squared. So as long as you know the radius of the sphere, then you just need to square it and times it by 4 pi, and it would give you the area of the surface. Learn all these formulae, okay, because you will need to know them, and make sure you understand how to apply this third when you're dealing with the volume of any pyramid. Okay, so we will now go on to some basic questions on these things we've discussed on the next page. Okay, first question. We have a triangular prism, okay? So it's like a Toblerone bar. You cut it along its length and it will always give you a triangle with a base of 5 and a height of 7. What's the volume of that? Well, quite simply, you find the area of the end or the area of the cross section, okay, which is a half base times height. So this is my working out, a half times 5 times 7. Now I can use multiplication signs instead. I tend to prefer brackets. And then you times all of that by the length of the prism, which is 9. Put it on the calculator and that comes to 157.5 exactly. Okay, and that is in centimeters cubed. Okay, first question done. And obviously it might ask you to give it to 3 significant figures, in which case you would give 158. Okay, the one underneath it is another volume question, very simple, asking you to find the volume of this pyramid. So what I do here is I just take the formula, which is 1/3 of the base area, okay, which is 5 times 4 okay, which is the area of the rectangular base, times the vertical height, which is 6. Okay, and that gives you exactly 40 centimeters cubed. Okay, and that's the volume of that pyramid. Okay, now we move on to this question, which is about a cone, and we've got to find the volume and total surface area of the cone. So there's two things to find out. Now, the volume, okay, of the cone is given by the formula 1/3 of the area of the base times the height. Now, by height, I mean 12 centimeters. That's the distance from the base, the middle of the base, up to vertically up to the top. Okay, so it's 1/3. The area of the base is pi times the radius squared. So it's pi times 5 squared. Okay, times the height, which is 12. So the 13, which is the slope height, doesn't come into this at all. And that gives us exactly 100 pi on the calculator. Okay, and if it wanted an exact answer, you would leave it like that. More likely, it would say give to 3 significant figures. Well, pi is 3.14, so that would be 314 centimeters cubed to 3 significant figures. Okay, and that's how you would present your answer to that one. Now, to find the surface area of the same cone, okay, we use the fact that the total surface area is the area of the curved piece, okay, round here, plus the area of the circular base. Okay, well, the area of the circular base is just going to be pi times r squared. Okay, so it's pi times 5 squared. Okay, and the area of the curved piece is pi times the radius times the slant height, and we're told that that's exactly 13. So basically we add those two things together and it will give us pi times 25 plus pi times 65, okay, which is actually going to be 90 times pi, 90 pi. All right, that's the exact answer, and if we put that on the calculator and round it to 3 significant figures, we get 283 centimeters squared, okay, because this is area now, not volume, to 3 significant figures. Okay, so be careful to include the correct units of measurement. Okay, now we come on to a question over here about the volume and surface area of a cylinder. Well, we do the same kinds of things, but using the correct formula. So for the volume of a cylinder, we simply use the fact that it's the area of the base, which is pi times r squared, okay, and r is 3. So it's pi times 3 squared times the height, which is 8. Okay, and you're just literally multiplying all that stuff together. And that's going to be, well, 3 squared is 9, 9 eighths is 72. So the answer is 72 pi. Okay, that's the exact answer. And it may ask you for that, but if it doesn't, it probably will ask you for 3 significant figures. That comes to 226 centimeters cubed. Okay, and that's to 3 significant figures. And now the surface area of the same cylinder. So for the surface area of a cylinder, it means the curved piece plus the 2 discs at the end, if you like. Well, the surface area of each circle at the end is pi r squared, so it's pi times 3 squared, but there are 2 of them, a top and a bottom, so it's 2 lots of pi times 3 squared. Okay, so that's the top and the bottom. But what about the curved piece? Well, you see, if you took that curved piece and cut down the length of the cylinder and unrolled it, you would actually end up, I'll just quickly sketch this for you so you understand what's going on here. You would end up with a rectangle. So like imagine a toilet roll cylinder. If you cut it down the length and unrolled it, it would be a rectangle. And the height of the rectangle would still be 8, okay? But the length of it would be the same as the circumference of the circle. And the circumference of the circle is 2 times pi times the radius, which is 3. Okay? So, in other words, that's 6 pi. Okay? So, that's the surface area of the curved part of the cylinder. So, it's going to be plus 6 pi times 8. So, it's 8 times, well, okay, if you like, it's 8 times 2 times pi times 3. That's what I've actually done to get that. Okay, but if you multiply that all out, that of course comes to 48 pi, and this comes to 2 pi times 9, which is 18 pi. So 48 pi plus 18 pi is 66 pi. Okay, and 66 pi on the calculator comes to rounded to 207. That's 3 significant figures. 207 centimeters squared, because it's surface area, to 3 significant figures. Okay. Right, and finally we have a question about a sphere of radius 8 centimeters. We don't need to draw a sphere. It would just look like a circle in 2 dimensions. But we know its radius, and that's all we need to do. So its volume is simply 4/3 of pi times the radius cubed. Okay? And you just put that into the calculator. And initially it would give it to you in exact form. And that comes to 2048 over 3 pi. So it would give you that on the calculator first. Okay, and then you put that into, well, if you press the SD button on the calculator, it will decimalize it, and to 3 significant figures, it's 2140 centimeters cubed. That's the volume. I think it's 2144 and something, but to 3 significant figures, 2140. Okay, and finally we're going to work out the surface area, and we just use the formula for that, which is 4 pi r squared. So the surface area of the same sphere is 4 times pi times the radius squared. Okay, well 8 squared is 64. 4 times 64 is 256. So it's 256 pi in exact form. And if you decimalize that, it comes to 804 centimeters squared to 3 significant figures. Okay, so just to give you an idea of the size of that, so 8 centimeter radius, that's a 16 centimeter diameter. So that might be the diameter of a small football, maybe a small one that's been deflated a bit, or maybe a child's one. Okay, and what this is telling you is that if you were to have little 1 centimeter squares and stick them all over the ball, you'd get about 800 of them to cover the surface of the ball. Okay, just to give you an idea of what sort of scale we're talking about there. Okay, and I hope that was a helpful introduction to area and surface area and volume of 3D shapes.